Assalamualaikum and hi everyone. So in this video, our group will present about technique of differentiation. So differentiation is an important topic in calculus that help us to understand how a function change and how quickly those change occur. One simple function can be differentiated using basic rules. More complicated function require specific technique. This technique allow us to find derivatives more efficiently and accurately. One of the most common method include is the product rules, quotient rules, chain rule, and implicit differentiation. So in this presentation, we are going to introduce this technique and explain when they are used and provide example to help illustrate their application. So by the end of this video, you will have a better understanding of how differentiation technique are used in solve mathematical problems. So this is our group members. So my name is Zaim Junaidi bin Helmi. So I'm going to present for the question 1. So this is Muhammad Daniel Adam. He's going to present for the question 2. And this is Muhammad Haris. He's going to present for the question 3. And the last one is Wan Muhammad Hafiz. He's going to present for the question 4. So this is the technique of differentiation. First we have constant rule. So the derivative of constant is 0. So this is the formula for the constant rule. Next we have power rule. Power rule used to differentiate the power of x. So this is the formula for the power rule. And next we have chain rule. So it's used when a function is inside of another function. So this is the formula for the chain rule. Next we have quotient rule. It's used when one function is derived by another. So this is the formula for the quotient rule. And here we have product rule. So it's used when two functions are multiplied. So this is the formula for the product rule. Alright, right now we have exponential rule. So it's just for differentiating exponential function. So this is the formula for exponential rule. Next we have trigonometric rule. It's used for differentiating sines, cosines, tangent, and other trigonometric functions. So this is the formula for the trigonometric rule. And the last one we have logarithm rule. So it's used for differentiating logarithmic function. So this is the formula for logarithm rule.
Alright, moving on to question 2. The question states that differentiation with respect to x, and here is the question given. In this question, we have to use the product rule because there are two functions that are multiplied together in this question. So, first of all, we have to find the value of u, which is ln square root x. And we will remove the square root by converting the square root into the power of 1 over 2. And then we will move this 1 over 2 at the front of the number. For the value of v, we will take this value from this question, and for the value of u prime, we have to differentiate the ln x, and it will turn into 1 over x. And when it is multiplied by 1 over 2, it will become 1 over 2x. For v prime, we have to differentiate all of this using the topping method, and the value of v prime will be this. So knowing that we have to use the product rule, we will put it on this formula, which is vu prime plus the uv prime, and then we will put each value one by one, and the final answer we will get this, which is secant exponent sine x plus 2 over 2x plus exponent sine x cos x secant exponent sine x plus 2 tangent exponent sine x plus 2 ln x over 2. Alright, moving on to question B. The question states that differentiation with respect to x, and here is the question given. In this question, we have to use the quotient rule because it appears that it has a numerator and denominator. So just like before, we have to find the value of u, which is 2x cubed, and the value of v, which is 1 minus tangent 3x. For the value of u prime, we have to differentiate this value, and it will become into 6x squared. And for the value of v prime, we will differentiate the value of v, which will become negative 3 secant squared 3x. Knowing that we will have to use the quotient rule, we will put it on this formula, which is vu prime minus uv prime over v squared. So we put each value one by one, and the final simplified answer will be 6x squared minus 6x squared tangent 3x plus 6x cubed secant squared 3x over 1 minus tangent 3x by the power of 2. Alright, that's all for me. Thank you.
Hi guys, my name is Haris and I'll be answering question number 3. So the question given to us is exponent 3x squared plus x squared cos 2y equal to ln x squared. Find dy dx using implicit differentiation. So the first thing you guys have to do is separate them into three groups, which is group A, B, and C. For group A, exponent 3x squared, you guys have to differentiate it. So y prime equal to 6x exponent 3x squared. For group B, x squared cos 2y, you guys have to differentiate it using product rule. So let u equal to x squared and differentiate the u into u prime equal to x. The same thing happened. V equal to cos 2y and differentiate the v into v prime equal negative sine 2y times 2 dy dx. So now combine it into a proper equation. Y prime equal cos 2y times 2x plus x squared times negative sine 2y times 2 dy dx. So arrange it. 2x cos 2y minus 2x squared sine 2y dy dx. So now for last group, ln x squared, you guys have to differentiate it. But before that, you guys have to bring the power of 2 to the in front. So y equal to 2 ln x. And now it's time for you guys to differentiate it. Y prime equal 2 over x. So the last step you guys have to do is combine all the group A, group B, and group C. So 6x exponent 3x squared plus 2x cos 2y minus 2x squared sine 2y dy dx equal to 2 over x. Arrange it into a proper way. Negative 2x squared sine 2y dy dx equal 2 over x minus 6x exponent 3x squared minus 2x cos 2y. So to eliminate the negative in front, you guys have to times the full equation with negative 1. So it's gonna be 2x squared sine 2y dy dx equal negative sine negative 2 over x plus 6x exponent 3x squared plus 2x cos 2y. So now arrange the right hand side. 6x exponent 3x squared plus 2x cos 2y minus 2 over x. So to find the dy dx, you guys have to divide the equation with 2x squared sine 2y to get the dy dx. Okay, now to simplify and remove the fraction in the numerator, multiply the top and bottom by x. So dy dx equal to 6x squared exponent 3x squared plus 2x squared cos 2y minus 2 over 2x cubed sine 2y. So finally, we can divide every term in the numerator and denominator by 2. So dy dx equal to 3x squared exponent 3x squared plus x squared cos 2y minus 2 over x cubed sine 2y. That's all from me. Thank you.
Okay, hi. Today I want to answer the question of 4. The question is, use linear approximation to estimate the value of 463.98 minus 63.98 power of negative 3 over 2. Correct to 4 decimal places. First of all, if we got the linear approximation question, we can use this formula. As we got from the question, which is 63.98. And SO, we got from the nearest whole number from the x. We got S and SO, we can use to this S minus SO. And we got negative 0.02. Find this FSO. And we change the number of S to the SO. And we got 2.8265. After that, we should find F prime SO. At first, we should do a differentiation to Fs. We simplify it for root s to s power of 1 over 4 and do a differentiation. 1 over 4, we bring it to the front, and 1 over 4, we minus it with 1, and we got 1 over 4 s power of negative 3 over 4. And same here, minus 3 over 2, we bring it to the front, and minus with minus we got plus 3 over 2 s of power of negative 5 over 2. Can we change the s with so? And we got this answer. And the final is we combine all the answer we got to this formula, this, and we got 2.8263 for the final answer. If you want to check the answer, put this from the question to a calculator and compare the answer with the final answer we got. In conclusion, differentiation is an important concept in calculus that helps us understand how a quantity changes with respect to another. Different techniques of differentiation such as the power rule, product rule, quotient rule, and chain rule make it possible to solve a wide range of mathematical problems efficiently. It is recommended that students practice differentiation regularly and apply this technique to various mathematical and real-life problems to strengthen their understanding.